So if 70% of the antibiotics sold in the U.S. are going straight to industrial animal farms or being fed to our meat production, what does that mean for resistance? I mean, I guess, since the CAFO or industrial farming is relatively new, considering it came out of World War II in the 40s and 50s, I think I've seen, you guys can talk to this maybe a little bit more specifically, but the numbers I've seen in the past, since the 80s, is that antibiotic resistance has increased by 60%. So it's obviously, we're coming to a point where we're not developing new antibiotics. I think the last one approved by the FDA was in 2001, but I could be wrong off a few years. So we're not really manufacturing, going out there, finding and producing new antibiotics. We're not approving them through the FDA, and antibiotic resistance is increasing. So this is kind of like, this is a problem that's, I think, only going to get worse. Do you guys agree? Anything else?
Yeah, I'll talk about new drugs in the pipeline. I think what you're referring to are there hasn't been a drug from a novel class. There's only been one since 1981. So we have some new antibiotics that trickle in every now and again, but almost all of them, with the exception of one, are from pre-existing classes of antibiotics. So we have a new cephalosporin, or we have a new this, or we have a new carbapenem. But they're really not that much different from the ones we already have. What we need are novel, really new antibiotics from a different class. And as Dr. Smeltzer said earlier, there aren't a lot in development. The main infectious disease organization, or I guess it's probably the only one, the Infectious Disease Society of America, started in 2004 a campaign that they called Bad Bugs, No Drugs, and it was a call to action and, trying to go the legislative route to sort of entice pharmaceutical companies to go down this road to discover and develop and research and bring to market new drugs. But I think the number I saw was that entire process from discovery to to having it on the market costs anywhere from $400 to $800 million. So again, and you have to remember, when a new antibiotic comes out, I say, great, don't use it. Because we don't want the new antibiotics to be wasted when we can use an older one. So, what is the motivation on the part of the pharmaceutical companies? And again, I don't have any tie to any. I'm just from their perspective, why would they spend that kind of money on a drug that somebody's going to take for a week or 5 days or 10 days, and we're going to say no, don't use it, when they can develop another drug that somebody's going to take for their lifetime? Drug companies really don't have an obligation to the public at large. They have an obligation to their shareholders, and the bottom line is money. And so that's why we need legislation that will give them incentive, whether it's a tax break, whether it's a longer patent, whatever it happens to be, to get them to develop new drugs, because there's not a lot in the pipeline right now. And it's a big problem. We need some new drugs just to stay ahead, because right now we have bacteria that cause infections that are resistant to all of the antibiotics that we currently have. So there are, again, I can name them, but there are, an Acinetobacter, for example, that is resistant to everything. And if you get that in your bloodstream, I can't do anything for you. And so we're in a desperate need of new antibiotics, but that pipeline is just real lean right now. We just cannot get the pharmaceutical companies to do this. And the other part of the first part of your question talked about animals and humans. I would just think of it as one big giant ecosystem. We just need to use less antibiotics. It doesn't matter to me if it's animal or human. We just need to use them appropriately. And the other part of that is it doesn't actually have to be a human drug given to an animal. There were clear instances where a drug only used in agriculture, the use of that particular drug was associated with human infections with the bacteria that was resistant to a human drug. So the specific example was something called avoparcin, which is just an animal drug. Use of that drug in the agriculture industry was associated with vancomycin-resistant enterococcus infections in humans. So it doesn't have to be the exact same drug either.
Do you have anything to add, Mark?
Well, the comment about one big ecosystem, that was a perfect segue, because I wasn't aware of that particular drug, but right now the greatest concern in my field is vancomycin-resistant Staph aureus. So the thing that we're trying to deal with is methicillin-resistant Staph aureus, but the way that we deal with it, the so-called last resort drug, is vancomycin. But in 2002, we saw the first case of vancomycin-resistant Staph aureus, or VRSA. Now, thankfully, and this is a knock-on-wood moment, so far it's very rare. Last time I checked, there had been 11 cases worldwide. And let me point out that VRSA, or vancomycin-resistant Staph aureus, isn't specifically the problem. VRSA in an MRSA strain is the problem. But when we started to see that happen, all but perhaps one case was, and Mike, correct me if I'm wrong, but my understanding is that there have been 11 cases worldwide, and with possibly one exception, those all occurred in patients that were co-infected with MRSA and VRE, with the bacterium that Dr. Sinte just referred to. So now you have a direct connection from the use of the agricultural use of an animal-specific antibiotic to VRE and now to VRSA. And if you think we've got a problem now, wait till VRSA becomes common. So again, that's a great example of all of it being one big ecosystem, and that's the way really it needs to be treated.